Hello, you're looking at a mid-1970s CB radio, and if you're somebody that's looked at some of my other videos, you're probably wondering what this is all about because most of my videos are about ham radio. Well, I reached one of those birthdays about a year and a half ago that is a nice round big number, and it's one of those where you start getting sentimental and nostalgic. And that is what happened to me. And I started thinking about some radio related things. I wanted to copy and restore my original novice station from 1977, which I had completely dismantled. I had a nice World War II receiver and a homebrew tube transmitter, and I just dismantled it for parts and never thought it would be worth anything, and now I want to put it back together. Well, another thing I got nostalgic about was CB radio. I got on CB in about 1973, right before I turned 11 years old. And as an 11-year-old, I didn't have much money, and I was definitely on a budget. And there were those big radios out there that I really wished I could have, and I never could. And I was thinking about those days, and what I wanted to do was have a restoration project where I would get one of those radios and just restore it. Now, there were several criteria for this restoration project. First of all, it had to be from the right vintage. So we're talking about mid-73, 74, 75. It was not one of those American radios that was sheet metal and, a lot of right angles. It was a radio like this that was Japanese and had a lot of chrome, and it looked fairly modern for that era. So I wanted one that was after the sheet metal age, but I wanted one that was before the 40 channel vintage where you had all the flashy 40 channel selectors and maybe a frequency counter and a bunch of 7-segment LEDs. I just didn't want that. I wanted something that reminded me of the time when I would go to the CB shops and see radios like this one, or, look in the publications. So I did some research and figured out which radio would be suitable, and I ended up with this. This is a unit-end chassis that has a phase lock loop in it. There were 4 versions of the Simba. This is the last, and it had the phase lock loop. I'll get to why I wanted that, but it was also a fairly good chassis. The same chassis was used by other manufacturers in their 40-channel designs. And I've been using it, and I gotta say, it's a pretty good radio. So anyway, the other criteria was that I had to be able to restore it near mint. It doesn't look like it in this picture, but this thing is beautiful. I've shown it to a few other people in the last week, and they are definitely envious of this thing. The chrome is beautiful. There's no scratches. It's just a beautiful radio. And I wanted to be able to use it, though, in a way that it would be more modern. I didn't want to be limited to the 23 channels, so I had to be able to get the 40 out of it, which sounds like a contradiction, because if I want it to be stock, which is that's one of my criteria, it has to be like a stock radio. It has to be like showroom. So if it's going to be like that, how can it also have 40 channels? And we're going to get to that in a moment. But suffice it to say, when you turn this radio on, everything is stock. All the buttons do what they should do. Now, if you're looking at this thing and you're more than a casual observer, you have already noticed that there are some things that aren't stock. The microphone connector is a 4-pin, which was part of the modernization. The S meter and SWR meter don't look like they're lit up by grain of wheat light bulbs, and you would be right. And if you really know your stuff, that channel selector that's green is wrong, but we'll get to that. That's part of the modernization, because the original was amber, and when you first turn this on, it is amber. So the other thing I wanted to do was to get rid of the old grain of wheat bulbs and replace everything with modern LEDs. And the mode indicators, the transmit indicator, the meters and the channel selector are all LED, and we'll get to that, and then I'll talk about the conversion to 40 channels. And then I'll show you a video of me using it that way. So let's move on. There is the AM indicator. It looks kind of bluish green, and you'll see in a later picture that it really is green, but for some reason with this camera it looks bluish green. That's an LED. Same right there, USB is lit up with an LED. Same right there, LSB. And there is the real color, and there's the transmit indicator. Now this picture makes that plastic look really beat up, and it doesn't look that way. I'm not sure why it did that. It looks really beautiful. I have two donor Pearce Simpson Simbas that I had to take parts from to get this one final one. So 3 radios total to get something that looks really good. Alright, we're going to move on to the 2 meters. Those are lit up with LEDs. By the way, I'm going to show you the backside of all these in a minute. And just to show you that that's not the room lighting it up, I'm zooming in here. Those are backlit by white LEDs. And then the channel selector. Okay, in the upper left hand corner is the LED display, I'm sorry, the bulb display from the stock radio. That's one of my donor radios. The actual Simba that I restored, almost none of the bulbs worked, including the channel selector. So the upper left hand corner is one of the donor radios, and that's what the amber looked like in the donor radio. And you can see the stuff kind of bleeds over into the channels to the left and right. To the upper right hand is the LED version. That is a mixture of red and green, and I also put some heat shrink tubing around the LED to try to minimize the amount of bleed into the adjacent channels so that it looks a little better. Then in the lower left hand corner is what the red LED looks like by itself, and the green LED is in the lower right. Alright, moving on. Whoops. Okay, there is the inside of the radio before anything was modified. So let me show you what's going on here. This area right here, those 3 grain of wheat bulbs are used to light up the 2 meters. And only one of those was working. And right here are terminal strips that are used. They have series resistors that limit the current going to those grain of wheat bulbs, supposedly to extend their life. I ended up using those same terminal strips for the different value of series current limiting resistor for the LEDs, and all of the bulbs on this used those terminal strips. These 3 bulbs, and the bulbs that are here for the mode, and the bulbs that were in this area for the transmit indicator. So going left to right, this is where the mode bulbs were, and right here is where the transmit bulb is. And the transmit bulb is just laying in there horizontally, glued to the surface, which I'll show you in a minute. And this little tab here is holding it in. Alright, next picture. This is the cavity that's for the transmit bulb. It was sitting right here. I removed it, and I want to put an LED there, and the only things I have to secure it are these 2 posts. So I made a little bracket right there that fits perfectly with those 2 posts. And by the way, a lot of the LED pictures look brighter than they are. That looks like it's overwhelming, but it's just the response of the camera. It's not really that bright. And then this is what it looks like mounted in this area right here. And as you can see from the first pictures, it works pretty well. I'm using the same blue wires that were used to power the original bulb, and then they go over to the terminal strip, and I just changed the value of the resistor so that the brightness would be proper. Okay, now for the mode indicators, I had to do something a little different. Since they sit in 3 cavities that are next to each other, you have to make sure that when one of the LEDs is on, it doesn't bleed over into the other cavities, which is a real problem. And the original design, they used grommet kind of things to go over the bulbs to limit the amount of light that would be emitted into the adjacent cavities. What I did here was, oh, there's another requirement. I have to make them so that they're adjustable in depth into the cavity, because I need to make sure that the focal length is right so that I don't have a spot beam or I don't have something that is extremely weak. So those are adjustable. So I've got the heat shrink tubing that is around each LED to make sure that it doesn't spill over into the adjacent cavity, and then they're also adjustable, and then when I have them at the right focal length, then I put some either RTV or in this case epoxy on them to keep them in place. And there's the rear side before the epoxy, and there it is installed, and you can see the lower sideband LED light is on. Okay, now this is the most interesting part of the radio. So this area right here, this is a bracket that was meant to hold the 3 bulbs in place, and it's held in by 2 screws. And over here is the channel selector, and right here is the bulb that it was a grain of wheat bulb, and then it went through the filter that was on the channel selector to give that amber color. I end up putting a circuit board in this area, so try to remember what this looks like, including this resistor here, which I had to put on the bottom to get out of the way so I could put a circuit board there. Anyway, back to this right here. This bracket holds these 3 bulbs, and in the next picture there's the bracket plus a little brass bracket that I made that attaches to it. So one LED went one bulb went here, another bulb went here, and another bulb went here. I fabricated this brass bracket, then drilled the holes so that the LEDs would fit in it snugly, and as you'll see in the next picture, once I'm done with that, I epoxy them in place, which will be this picture right here. So there is the brass bracket, and there are the LEDs epoxied in place. And over here is the terminal strip I was talking about. There's a changed resistor right there. And go to the next picture and you'll see the thing turned on from the back. There it is lit up. And like I say, they're not as bright as they look. It's an artifact of the camera. I can't do anything about it. Okay, on to this area. Okay, so if you remember the picture before, there were 2 red wires going here that were powering the bulb that was in there. Well, I'm now setting 3 wires there because I'm powering a green LED and a red LED, which are being controlled by this microprocessor. And here are the wires that are coming out of the channel selector that go into this connector. This connector connects the input side of the channel selector to this microprocessor. Then it determines what's going on with the channel selector, selects the right color of LED, either in this case amber or green, and it also uses this connector right here through the ribbon cable to send data to the PLL module to control the frequency. There is the resistor I was talking about that I had to put on the bottom side. I used the same terminal strip to mount it on the bottom. It's almost in the same place, just on the bottom instead of the top. Right there you can see the 4 standoffs that I mounted on the chassis there so I could mount the circuit board, which is right there. So there it is without anything connected to it, and right here is the connector that connects it to everything that's in the radio that I need, like the channel selector and the LEDs on the channel selector and power. And then this right here, this ribbon cable, is what goes to the phase lock loop module. There's a close-up of the board outside of the radio. There's the underside of the board, point-to-point construction. No printed circuit board was even attempted here. Here's the schematic for those of you that are interested. So here's the channel selector right here. Here's the stock wires with their colors. And here's the indicator that tells you you're on the position 22A, which is the little gap between 22 and 23. And what they did originally was that would tell the radio to be disabled. I'm using that right now to detect when it's in that position, and you'll find out shortly why. So, wires come out of here. This is the BCD information. It goes over to the input side of the microcontroller, and I've got some pull-down resistors here because all these do is supply 5 volts, they don't go to ground, so I had to pull it down just like it does inside the phase lock loop module. Then the microcontroller goes over to the PLL with the right data depending on what I want it to do, either channels 1 through 23 or I go up to 40 in another mode. Here's the output controlling the LEDs. That goes over to here through these 2 resistors and then these LEDs right here. This is the programming interface so that I can program the microcontroller when it was in circuit. This transistor is in place to disable the radio if it's on a channel that's outside of the 40, which is a possibility, and I circumvent it from transmitting with that circuit right there using the technology that was originally in the radio at 22A. Okay, now that's that picture again, but now you've got a bigger idea of what I did, and maybe it all makes sense right now. So I'm going to show you the video shortly of channels, well, going up to channel 40, but I wanted to address one thing. So I showed that it had a 4-pin connector, which is right there, and it just wouldn't be a modern radio without that, because that seems to be a standard and there's a lot of microphones that are compatible with that. I have changed the mic connector on a lot of radios, and for some reason on this 40-year-old radio it was not going to cooperate. I don't know if something happened with the thread locking compound over 40 years and it just seized up, or if they used something like crazy glue in there, but the thing would rotate but it wouldn't turn, and no matter what I did. So I had to take extreme measures right here. I had to use a Dremel to get that thing off, and it was worth it, but I was starting to have second thoughts. Okay, here comes the video showing the channels up to 40, but maintaining the ability to be stock.
Okay, here we are with my Simba, and I have decided to put a frequency counter on this so that when I go to some frequencies you'll know that I'm not BSing you. Anyway, so here we're going to turn the radio on, and as I promised, when you first turn it on, the LED is amber just like it was when it was stock. And just to show you what's going on here, we're going to go through the frequencies and we're going to show you that everything is legit. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. When you go there, there's nothing, and then 23. Okay, so I promised that we would have the ability to be stock, but also the ability to have 40 channels. So watch what happens when I put it on the gap between 22 and 23. See that? Just turned green, and that turns red, and then it turns amber again. And it will keep doing that until you pick one. So I'm going to pick green when it rolls around, which it changes every 2.5 seconds. There's green, bang. Okay, I picked it when it was green and it stays green. It's going to stay green until you turn the power off again. So what good is this? Well, I have made it so that channels 1 through 20 are now channels 21 through 40. None of that 10 kilohertz gap stuff between 3 and 4. There's no problem. It's just pure and simple. You add 20 to it. So 21 would be channel 1 and channel 40 would be channel 20. And then the other channels don't do anything. So 21, 22, and 23 are blank. And that's the way I wanted it. It's just pure and simple. So let's show you. Alright, there's channel 1, which should be 21, which if you look at the freq counter it is. There's 22, there's 23, which would be 27255 because of that funny jump. There's 24, there's 25, and there's 26, 27265, there's 27, there's 28, there's 29, there's 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, I just unkeyed the radio, and like I said, if you turn the power off and turn it back on, it goes back to stock. There it is, amber.
Okay, well, that's my Simba project. I'm going to wrap this up here. This radio took about a year to finish, from the first desire to start it to actually finishing it now. It took the better part of the year just to find this Simba SSB too. Along the way, I also got the 2 donor radios, and that was required in order to get the plastic and the meters and the knobs and the cool microphone that I didn't show. It comes with a Pearce Simpson CB microphone, which is very unique. It doesn't look like anything else. There was some minor damage to this radio when I received it. One of the knobs was damaged, and one of the knobs on the mechanical clock was damaged. I was able to replace the knob and the pot with one of the donor radios, and I was able to apply just a little bit of pressure to the mechanical clock switch, and now it looks perfect. There was really no electrical problem with this radio, other than there was a problem in the loop filter of the phase lock loop. Some of the capacitors has aged, and the response of the loop filter was not very good. So I replaced those with some newer caps, and that came right back to life and is working well. You may be curious about the red LED. That is a mode that I may get back to someday, where I may make this go to the 10 meter amateur band. I did some experimentation with this radio, and I believe that with just a little bit of coaxing, with changing some capacitance either through pin diodes or varactor diodes, as I change the frequency, I could get this radio to cover very satisfactorily about 1.5 megahertz, which would include the CB band and the 10 meter amateur band that I'm interested in. Anyway, I hope you've enjoyed this, and I know that I am.